Next up, we have oral presentation 12, San Jose, California, Team 1, Mission 12 Finalist Proposal.
Hello everyone, I'm Shiri Kaguchi and this is Malia Francis. We're very excited to be here today as representatives of our school. Our teacher facilitator is Jessica Davis.
We're 7th graders from Discovery Charter School in San Jose, California. Our proposed experiment was to observe the effects of microgravity on Artemia cysts, which are also known as brine shrimp. So, who here knows what brine shrimp are? Raise your hand. All right, so a few of you.
Has anyone raised them before? If you raise sea monkeys, that counts.
Okay, so yeah, a few of you know about them already. For those of you who don't know,
Brine shrimp love salt. They primarily live in the Great Salt Lakes around the world.
they can also live in your fish tank as fish food.
Even though they do love salt, sometimes it's too salty for them. In that case, instead of laying eggs, they lay cysts. Cysts are dehydrated eggs that will hatch when the right amount of water and the right amount of salt or perfect salinity are cured.
This was perfect for our experiment because we could keep them dormant before the astronauts merged them with water aboard the space station. We used this quality of brine shrimp in our experiment. Our experiment was actually designed to replicate human babies born in space.
We saw the probability of this happening in the near future, so we wanted to simulate it. We monitored size, color, body organs, and movement.
Our original experiment was composed of 7 milliliters of water, 175 milligrams of salt, 175 milligrams of spirulina powder, and about 2,000 brine shrimp cysts. This was pretty hard to measure, and in that case, we had to somewhat estimate. Unfortunately, all of the shrimp died within 2 days, and it got so bad that a cloudy film of dead brine shrimp formed above the liquid.
These are what the bad vials look like. It's pretty obvious that it's really not a good environment for the baby shrimp or even any kind of organism.
So also, as seen in this photo, you can see a lot of eggs clinging to the dry surface of the tube. So this may have affected survivability, and because there would not be as many viable eggs.
At the 3-week mark, we confirmed that there had been none alive since day 2, so we threw out the liquid inside. It smelled really bad.
We came up with a list of bad variables. Those included too much salt, not enough space, air, or hatching buffer, and also too much spirulina powder and eggs. We also thought that we should have done more trials. We thought that the ones affecting our experiment the most was air and spirulina. Like us, brine shrimp need to breathe. So if we cut off the oxygen, they will die. The food, we added too much food because, as you saw in the photo, the water was lime green, and that was very unhealthy for them.
So applying all of this, we improved our experiment. So we used 30 milliliters of water, no spirulina powder with soybean powder instead, even though this version really wouldn't work on the ISS because the tube's 10 milliliters. And we would also have to cap it, but we used gauze so they could breathe. This was very constraining, but we agreed we would make it purely to figure out what went wrong. And amazingly, they lasted 4 weeks.
Yeah, that was way better than the first one. A source that we found only got theirs to survive about 2 weeks, so we got it 2 times better than them. And their population rapidly deteriorated after the first 2 days. During those first days, the brine shrimp survive off of their yolk sac so that all that hatched would live. There are about 100 of them in the vials at the time. By 2 weeks, there are only about 10 shrimp per vial.
These 2 pictures are taken about day 2. I'm not sure if you can see them, but those little tiny dust dots are brine shrimp.
They seemed to be attracted towards the window, which was an interesting observation. We thought that they liked the light. From this experiment, we learned that our original experiment did not have the right variables to support a population of brine shrimp. We also discovered that if we performed a hypothetical experiment on the ISS with 30 milliliters of water and less spirulina powder, the environment would probably have been pristine. In orbit, we would probably get a similar results with weakened shrimp because being on the ISS weakens human bodies as well.
We'd like to thank these following institutions for helping us, along with SSEP and Smithsonian Institution, among others. Yeah.
Thank you.